Okay, next we're going to look at is this thing called an SEM, or a standard error of measurement. Basically, what happens is every time that you take a test, if as long as it's the same test and nothing else changes, you're going to get another score that is going to be pretty close to, hopefully, to the score that you got before. How far off you are from the last time is this standard error of measurement. And when we start doing that for lots and lots of people, we can start to generate a reliability score. I'm going to jump down here to the bottom of this. One of the things that you'll notice when you read about reliability is you get a coefficient number, R. That's kind of like a correlation coefficient. It's on a scale from 0 to 1, and the closer you get to 1, the more reliable the instrument is. Going back to this SEM, when we look at standard error of measurement and reliability, they tend to be correlated to each other, meaning that if I have a very low SEM, meaning that there's not much variation between each time that I take a test, then I have a very high reliability. If I have a lot of error each time I take this measure, then I have a very low reliability. So those two things are correlated. A standard error of measurement has to do with an individual's score. Kind of like a standard deviation for a group has to do with how much difference there is between one group and a whole norm group. This has to do with how much variation there is between your score one time and your score a second time. When there's very little variation between those 2 points, you get really good reliability. When there's a lot of variation between them, you get low reliability. Oops, that's not what I meant to do. The other thing that I want to put in this document, this SEM, this is going to be the notes page, so you can go back and look at. The other thing I want to put in there is this types of internal reliability. And basically, this is just a chart that explains what a split half is, what it's used for, and how it's done. What a Coulter-Richardson is, what it's used for, and how it's done. So it's kind of a synopsis of what you have read in your chapter, and that'll be available in there as well. Okay, people always ask, well, what number is okay? Well, it depends on what you're doing. If it's exploratory research, if it's the first time an instrument has ever done the reliability coefficient can be as low as 0.6 and still be okay. If it's something that's been used before and you're rechecking it, then adequate reliability is a 0.7, good reliability is a 0.8. So if this is an existing survey that you're going back to check to see if it's still reliable and you get a reliability coefficient of 0.55, that's not okay. You don't want to use that. That means that over time that instrument has become less reliable. A few misconceptions. One, and this is kind of hit on this just a second ago. For researcher A uses a test that researcher B built a year ago and documented as being reliable, then researcher A can use that test today and have full confidence it'll be reliable for him or her. You can't. If you're going to use a survey again, one of the things that you need to provide in the data is a reliability coefficient. As I said, the most common one is that Cronbach's alpha. The reason why is that over time, the way people respond to questions changes and the circumstance changes. Your circumstances are different than the circumstances under which that survey was built. So that's one of the reasons that we can't use it without providing that data to it. And it may be that when you provide that again, that reliability data again, that it's fine, but it's important to include that. The other misconception is this high test-retest reliability implies high internal consistency reliability. You can have an instrument that each time you use it, you get the same score. But that doesn't mean that the scores within that instrument, this internal consistency, are reliable. Those two things are separate issues and need to be treated as separate issues. You can have a survey that has high internal consistency, meaning that all the questions load together, but that doesn't mean that's going to do it every single time. So both issues need to be checked. Those are separate issues. The test-retest and the internal consistency. Let me say it one more time. If we have a survey and we use it one time, do something to them, and retest them again, that doesn't necessarily mean that that all the questions in that survey load together. We'll get the same answer twice, but that doesn't mean that all the questions within that survey have anything to do with one another. The other side of that is just because those questions have something to do with one another, that's not enough. If it's a survey that we're going to use again, or we want to make sure that regardless of when it's used, it has retest reliability, that's a separate issue, and they need to be treated as separate issues. Validity. Simply stated, validity is how well a survey or an instrument or test or observation measures what you meant for it to. So reliability has to do with how consistent it is. Do you get the same answer every single time? Validity is if you use a survey and that survey is about sense of belonging, does that survey really give a perception of what people feel or what their sense of belonging is? Or if you use an observation like teacher observation, if you get a high score on that, does that really indicate good teaching? If you get a low score on that, does that really indicate poor teaching? That's validity. Reliability is how consistently it does it. Okay, there's basically 4 different types of validity we need to concern ourselves with. One is content, meaning does a test measure somebody's understanding of their content? For example, a social studies test, does that really measure what you wanted it to measure in terms of the student's understanding of a social studies issue? Criterion has to do with there's 2 subparts to it. One is concurrent, meaning if you make a new version of the same test, for example, if we make a new GRE test, does it give us relatively the same type of information as the old one? Or if we make different versions of a test, if we make a survey for high school students, can we make a different version for junior high students and get relatively the same answers? The next one is predictive test. For example, the GRE is supposed to be a predictor of how you will do in college. And the last type is construct validity. If we are trying to measure the construct belonging, and we have a set of questions, does your response to those questions really portray how your sense of belonging, how you feel? One of the things I want you to look at in the discussion board is this type of validity. And these are real short, and what I want you to do is respond to what you think A, B, C, and D is. So I'll put that up in the discussion board with some directions. The other thing I want you to look at is this relationship between validity and reliability. If we have a rifleman and he's got a rifle that's locked in a scope or locked in a set of blocks so it can't move. So we know the rifle can't move. We know our rifleman is very good. We want to know if his rifle is valid and reliable, meaning that does his rifle hit where it was supposed to hit, and does it do it every single time? So in Target A, we have a situation where each time he shoots, he's shooting in a different place. So in this situation, his rifle is not hitting where he wants it to hit, and it's hitting in a different place every time. So this rifle is not valid, and it's not reliable. In this situation, every time he fires the gun, it hits pretty close to the same spot up here. But it's not shooting where he wants it to. So here we have a situation where his rifle is reliable, meaning it does the same thing every single time, but it's not valid because it's not hitting where he wants to hit. So this is neither valid nor reliable. This is reliable but not valid. Come down here, it hits where we want it to hit, and it does it every single time. So this is valid and it's reliable. Now, what I want you to do is to print this off in the discussion board. explain to me, and you can post these back up on the web or send them to each other, how can we have a rifle that is reliable but not valid? Excuse me, that is valid but not reliable. This one up here is reliable but not valid. How could we have a rifle that is valid but not reliable? Where would the targets hit, assuming that what we want is to hit it right in the center? So I'll put that on the discussion board as well.